Hello everyone. In this video of mechatronics, we are going to look at 7 segments, the digital displays that you see in so many places, including digital clocks. And the reason we call them 7 segment is because they have 7 basically LEDs. As you can see, they are shown by letters A all the way to G, and so you start from the top one A and then you go clockwise B, C, D, E, F, the middle one is G, and then there are actually 8 LEDs, but these 7s are shown used for showing numbers, and then there is decimal point or DP if you want to show numbers with decimals. So there are really 8 segments, but the major ones are 7. And there are different colors. The most common one is red, as you can see here, right? Let me show you my circuit right now. So here I have Arduino Uno, and it shows number 0, 1, 2 all the way goes to 9, then just the decimal point, and then repeats the cycle. Okay, so I'm gonna explain this a little bit, and then I'm gonna show you one that has 4 digits, a 7 segment that has 4 digits, and I use that to count with fractions and go up. So the way that we talk about 7 segments and the way we wire them is by first knowing what basically type of 7 segment it is, which pins are which, and how each one of them is connected to one of these LEDs. So the 7 segment I'm using right now, the single digit one, is type 5161AH, and for basically series 5161, this is their pinout, and these are their connections of the pins to those LEDs if they are common cathode or common anode. Okay, so if they are common cathode, all cathodes are connected together. Each segment is activated by sending it a high voltage. In common anode, the anodes are connected and each segment is activated by grounding it. So you have to send them low in common anode. In cathode, you have to send these pins high. And the one I have right now is a common cathode. Typically, the A series in any 7 segment, they are common cathode, and the B series are common anode. And the one I have is AH, so mine is common cathode. Okay, so I have to send the pins a high voltage. Now, out of these 10 pins, which one is turning which on? So if you look here, there are 10 pins. So starting from here, 1, 2, 3, all the way to 5, correct? And then going all the way back over there on the other side to pin 10, right? So the way you go about the pins is counterclockwise. So you go there, that pin over there is 6, then you go 7 all the way to this one that becomes 10. So with these 10 pins, which one is connected to which? If you look at this wiring diagram, you can see that for common cathode, which is the one we have, pin 1 is going to turn LED E. So when you 1 is going to turn this one on. When you go 2, that's D. When you go 3, right, you see that 3 here that is the ground, right? The same goes for pin 8. Both of these middle ones here in the front and back, as you can see them, I added this picture for you. They are connected to ground. Now one of them is enough in this case, and that is what we are going to do in this picture here. You see this one is connected to the ground of Arduino. And then, of course, C is connected to 4, so this one is 4. And then 5 is the decimal point, 5, then 6 is B, 7 is A, 8 is again ground, 9 and 10 are F and G. Okay, so this is the connections that we have, and that is how we are doing it. By the way, here, this wiring diagram and the code that I'm going to show you are taken from this website, Project Hub for Arduino. Okay, that's a good website. And so here they are all, if you look at these 8 pins for the 7 parts of the number, these A, B, C, D to G and decimal, they are all connected by resistors to the pins to limit their current. And the resistors that I'm using right now, they are all 220 ohms. Typically you need somewhere between 200 to 300 to limit the current going through the pins so you don't overheat them over time. Okay, so these are the resistors that I used, and then I wired them to the corresponding pins, as you can see, of Arduino. Okay, so these are pins from 4, 5, 6, 7, 8, 9, 10, and 11. These are the 8 pins that I connected to the 8 LEDs here, and then by sending them appropriate high commands, I'm going to turn them on and off. So here, if you look at the code, by the way, this code had some mistake. This C that I picked from the website, this C should have been 5, it should be 4, it was 5, so it was not working, and decimal was 4, but it should be 5. So I just changed this portion of it, and I added one extra thing to show decimal point. The code I got from website did not show decimal point, so I added that. So the way it is doing it right here is without a library. So you're doing it the hard way. You define your pins that are connected to each one of those letters. Okay, these are your pin numbers. Pin 11 goes to D, pin 4 goes to C. And then to turn each one of these LEDs on and off, you define a function for it. So you see here, by void display 1, that is a function. Doesn't need any input, doesn't return any output. All it does will send high voltage, you see digital write high, to pins B and C. And B and C, if you remember, are the ones on the right side. So if I turn this one on and I turn this one on, then I'm going to show number 1. Right? Similarly, number 2, I need to turn on A, B, G, E, and D. Okay, so if I show you A, B, G, D, and E, this is A, this is B, this is G, this is E, and this is D. So you clearly see I'm forming number 2. So by forming the turning on the appropriate LEDs, you can form any of these numbers. So I create a function for showing each and every one of the numbers, and then I go all the way to 9, 0, and then I have added 2 extra things here. One is the decimal point. The only thing you need to do for decimal point is to do the decimal point high, which is pin 5, or basically pin 5 of the 7 segment in this case. And then there is one that is clear LCD, and you're sending all of them low. Okay, you're sending a low to all of them, and actually it's appropriate to add a low for the digital pin as well. This way they are all going to be basically off, and so that is like you're cleaning up the LCD and you're not showing anything on LCD. Okay, so I wrote a bunch of functions. Now if you put these functions in a library and you give a function to these, then that's what we're going to do in the next part. But here no library is used, and you see here in the setup what I'm doing is I'm first sending setting up each and every one of the pins to be an output pin. Okay, so that's all I did from pin 4 all the way to basically pin 11. So all of these pins I set them out to output. Pin mode I output. So instead of this, I could have written pin 4 output, pin 5 output, pin 6 output, right? But here it's just done in a for loop. It's no big deal. Then in the loop, the part that I need to do, look what I do. First I clean up the screen, then display 0, wait for 1 second, clean it up so I can display 1, wait, clean it up, and then keep going, display 2, 3, 4, all the way to display 9, then display decimal, and then go back and start from 0 again, right? So if I go ahead and send this to my Arduino, you are going to see the result that you just saw. So let's send it. There we go. 0, 1. There we go. 0, 1, 2, 3. Right? 4, 5. It counts up to 9, shows the decimal point, and goes back to 0. Right? So this is using a 7 segments with single digits without any library. Now, if you want to do more advanced things, right, for instance a clock or anything, that's where you can use a library. So here, the second code, let me show you the second one. For the second code, I am basically using a different Arduino with 4 digits. So this time I'm going to use SH5461AS, again because this is A, it is a common cathode. It has 4 and 4 basically decimal points. Now the pinout for this is what you can see over here. There are this time 12 pins, not 10. There are 12 pins, and let me connect that and get it running so you can see it. Okay, so here I'm sending the code here, and you see that it is counting up, right? Counting all the decimals, 7, 8, 9. It's kind of like what you see when you are filling your car with gas, right? These digits are counting up, so that's basically something like this, several decimals. So you see it's a counter, and this time it is working with 4 digits and it's counting up. So how does this work? First of all, here I'm using a library. This library is called SevSeg.h. So I included that. And if that library is not installed, you have to first install it. So you have to go here, click there, and then you have to search your library and make sure you install that library. Okay? So you see here it is installed. If it's not, you can install it. Now I installed the older version of this, not the 3.7. I installed the older version, so it is available to me. And I can call it. Then I create an object for it, SevSeg. Then you have to provide some information here. What are the information? First of all, how many digits does your 7 segment have? Clearly it's 4. Then the other thing we have to talk about is there are segment pins and there are digit pins. Okay, so we have to talk about that. So let's go back to this file here so I can show you what I mean by that. So if you look here, you can see that actually there are 3 digits, D1, D2, D3, and D4. So depending on, you send your signals to which one of these, one of those digits will be on, correct? This is DP1, as you can see, DP2, second one, 3, and 4. So which one of them do you want to turn on? That is the signal you send to D1, D2, D3, or D4. And then, these are 4 of that. The other 8 are the 8 pieces of the 7 segment. So pin A, pin B, C, D, E, F, G, and the DP. Okay, so each one of them has 4, and depending on which one of these D1 to D4 you pick, you can turn one of those. Okay, so here that's why you have 12 pins. And this diagram that you see, I picked, this is from the Wokwi website, the website I showed you in my first video, which is great for creating animation of the system, right? So that is this website here. Okay, and let me show you that. So if I pick this website and go there, you see you can get your circuit here. It shows you the circuit, it shows you the code, right? And then what? You can simulate it. And here, the interesting thing, I put the actual circuit for you right above it. So you can enjoy it further, right? So you see here, I put them side by side for you, so you can see the actual circuit versus the simulated one. And in here, no pin is directly connected with resistors. It should be ideally, but here for simplicity, I guess they did not put the resistors on. But if you want to limit your current and not burn that 7 segments in short time, you better put some 200 to 300 ohms on the way of each one of these pins. Okay, otherwise you can burn it in short time. But here, just for simplicity, it didn't do it, I didn't do it, but it's not a good practice. Now here is the code, and if you look at the code, let me show you. So first you say that which pins are the basically 1 and 2 and 3 and 4, those pins, and then which 8 are the ones for the 7 segment pins, so you define those. Then you say whether there is resistor on the segments or not. You see here I said it's false. Okay, I did not put anything on them. Then what is the hardware config? Is that common cathode or anode? The one that was written in WOCV, if you look at it, is common anode. And it's not going to work with this, the one that I have. So I changed it to common cathode so it works. Okay, and then do you want to update with delays? Okay, if you make it true, then it is going to go a little bit slower. So I can make this true, so it is not going to go as fast as this. And then do you want to show leading zeros or not? Do you want to disable the decimal point? I don't want to disable it. You see I'm using it. So you can basically do all of those options. So you see here, you set up all of those. Now this object SevSeg, you start it with the hardware configuration, common cathode, with the number of pins, with the digit pins, with the segment pins, whether there is resistor or not, delays, leading zeros, and decimal points. You start it, you set up the brightness of it, and then in a loop you are going to use it. So these are all the setups. You start it and you set the brightness. Now what do you do? Here, first you get values in milliseconds from a timer. Okay, so you create the variable timer, which is getting its values from the built-in function millis. This is reading the time in milliseconds. Okay, we don't need any deciseconds, we just need milliseconds. And then what do we do? If the millisecond minus timer is bigger than 100, we are going to add 100 to it. So we only update the milliseconds every 100 milliseconds. And how much is 100 milliseconds? 0.1 of a second. And if you look at this number here, only the 0.1, 0.2, the first, or every 100 milliseconds, this number gets updated. Okay? If I wanted to show every millisecond, I had to add another one here and use 2 more decimal places, but I don't want to. So all I do is every 100 milliseconds I update my number. That is what you're doing over here. Okay? And then look at here. When the deciseconds pass 10,000, I'm going to reset it to 0 and then set the number in decisecond and 1. So what am I doing here? Decisecond. Deci means what? Deci means basically 0.1 of a second. So 10,000 deciseconds means 1,000 seconds. And that's exactly what you have, because look at your number. You can only have 3 numbers on the left side of the decimal place. So you can only go to 999.9. When you go to 1,000, you have to reset it back to 0, because you only have 3 decimals on the left. That's what you're doing here. Okay? Go back to 0 after 1,000 seconds, only upgrade the first decimal and only show the deciseconds here, plus, and then show the deciseconds, whatever it is, which is so many seconds plus the first decimal, show it on 7 segment. So you see, this is your main function. This is the one that does the display. All you need is to pass a number to it with 3 numbers before decimal and 1 after, and that's all it does. Basically shows that number on the 7 segment, and then it has this other function, refresh display, that is basically cleaning it up. Okay, if you don't, this is going to be kind of fuzzy. You don't see transition from one number to the next. So this refresh display is like that clear display that I had for the single digit. And instead of all those different functions that I wrote for 0, 1, 2, here you only have one thing, set number. You use a method for this object 7seg, and it does all the job because I'm using a library which has all of those functions written in it. All I need is to tell it how this 7 segment is connected and wired, set the brightness of it, say whether it wants any delay or not. So let's say if I say true, would that give it any thing here, right? Whether it slows it down. Now you see, I assume it should be this one. It's case sensitive. Let's see whether that would slow it down. Yes, a little bit. It's a little bit better. And then let's change the brightness to maybe half of what it is. Okay? And see whether that would change the brightness as well. So you can change the settings here. Okay, a little bit. Maybe not super visible to you in the video, but to me it is a little bit less bright compared to what it was. And this is how basically you run 1 or 4 digit 7 segments. These are the code, and I'll try to upload this code and put them under video description for you, both of them. Again, these code are not mine. I just modified a little bit, and I'm gonna put them there. And with the circuits, hopefully you can replicate what I'm doing here. Hopefully this video was useful to you. I'll see you in the next lecture. Thank you.